Welcome to the Deep Dive.
Glad to be here.
Today, we're diving into a story that's, well, part incredible personal risk, part potential global breakthrough.
Mm-hmm.
We're looking at the quest for a universal snake antivenom.
And it's a journey that really started with one man and, honestly, an astonishing number of snake bites.
Right. So for this, we've got quite a few sources.
Yeah, we do. We're looking at news reports from places like Science News, the Indian Express, AP News, Discover Magazine.
Okay.
And also a really helpful scientific review from PMC PubMed Central that gives us the sort of broader scientific context.
Good, good. And the central figure here is a guy named Tim Friede.
That's him.
You might not know the name, but his actions. Wow. This is someone who intentionally allowed venomous snakes to bite him.
More than 200 times.
Over 200 times.
Yeah.
His initial reason was, well, practical maybe.
Yeah.
Self-protection, because he worked with reptiles.
Right, initially. But then it really grew into something else, a desire to help, the huge numbers of people affected by snake bites globally every year.
Yeah.
So our mission today really is to unpack how Friede's very unusual and, let's be honest, extremely dangerous path.
Definitely dangerous.
How that actually contributed to developing this new potential antivenom. And we also want to look at the bigger picture, the wider scientific efforts to improve snakebite treatments.
It's just such a striking story, isn't it?
Mm-hmm.
Someone willingly facing that kind of danger, staring down, some of the deadliest creatures on Earth.
All with this hope of creating something potentially life-saving for countless others.
Okay, so let's start with Tim Friede himself. What exactly did he do? How did this whole thing get started?
Well, he embarked on this nearly 2-decade process of self-immunization.
2 decades?
Almost. It involved injecting himself with tiny, then gradually increasing amounts of venom from various dangerous snakes.
Cool.
By the time he stopped doing this, around 2018, he logged something like 202 actual snake bites and 654 separate venom injections.
That's just mind-boggling. And it wasn't smooth sailing, was it? I mean, there must have been some incredibly dangerous moments.
Oh, absolutely. There's mention of 2 cobra bites that were really bad. An Egyptian cobra, and then just an hour later, a monocled cobra.
An hour later.
Yeah. Landed him in the hospital, airlifted, 4 days in a coma.
Jeez.
He even said himself it was stupid, acknowledged the risk. But he felt driven by the potential science.
I remember seeing a quote, I think it was the Sendivac CEO, Jacob Glanville. He made a comparison to the Princess Bride.
Ah, yes, the iocane powder immunity, Wesley building it up slowly.
Exactly.
Yeah.
It's kind of a funny analogy, but it does illustrate the principle, right?
It does. It shows how the immune system can sort of learn to fight toxins with controlled exposure over time, though controlled might be a stretch for Friede's method.
Definitely a stretch.
And beyond just protecting himself, the articles really stress his commitment grew. He wanted to help people in places hit hard by snake bites where antivenom is scarce or non-existent.
He said it just became a lifestyle, driven by people thousands of miles away.
Exactly. That dedication is quite something.
And because of all this exposure, his body developed, well, a unique defense system.
Totally unique. His immune system produced this incredible array of antibodies. They could neutralize toxins from over a dozen different venomous snakes.
Including?
Oh, things like coral snakes, black mambas, rattlesnakes, a really broad range.
Which, okay, that brings us to the problem itself. Snake bites globally, and why the current treatments aren't always enough, it sounds like a massive issue.
It really is a huge global health problem. The World Health Organization estimates maybe up to 140,000 deaths every single year from snake bites.
140,000.
Yeah. Another estimate puts it between maybe 81,000 and 138,000 deaths, but adds potentially up to 400,000 people left with permanent disabilities each year.
That's staggering.
And these aren't happening evenly, right? It's mostly affecting people in Asia, Sub-Saharan Africa, Latin America, parts of Oceania.
Places where medical access might already be difficult.
Precisely. It's a health crisis on the scale of some major infectious diseases, but it often gets much less attention. A neglected problem.
And the antivenoms we have now, they work sometimes, but they have drawbacks.
There's significant drawbacks, yes. First, most are species-specific.
Meaning you need to know exactly what snake bit you.
Right. Which can be really hard, especially if it happened quickly, at night, or in an area with lots of different venomous snakes.
Okay.
Second, the way they're made. Usually it involves injecting venom into animals, often horses.
Horses.
Yeah, horses typically. Then they harvest the antibodies from the horse's blood. It's an old method, late 19th century.
Wow. And that process, It's not ideal.
It's time-consuming, expensive, and consistency can be an issue. Plus, using animals.
And I read that the venom itself can vary,
Yeah.
even from the same type of snake.
Exactly. That's a key point from the review article. Venom can change based on where the snake lives, its age, even what it ate.
So an antivenom made from snakes in one place might not work as well somewhere else.
Correct. It reduces effectiveness, and because these antivenoms come from animals, people can have bad reactions to them.
Allergic reaction.
Yeah, serum sickness, sometimes even anaphylaxis, and then there's cost and just plain availability. They're often hardest to get in the places that need them most.
It's a really tough set of challenges. The WHO has flagged this though, right?
Yes, thankfully. In 2017, WHO designated snakebite envenomation a neglected tropical disease. Top priority.
And they set a goal.
They did. To cut deaths and disabilities from snake bites by 50% by 2030. It's ambitious, but it shows the urgency.
Okay, so that's the backdrop.
Yeah.
Now, how does Tim Friede's story connect to a potential solution? How did his antibodies get involved?
This is where it gets really interesting. Dr. Jacob Glanville at Centivax, a biotech company, was already working on broad immunity ideas.
Okay.
He read about Friede in the news, about his history, his resistance.
And thought, maybe this guy's blood has what we need.
Pretty much. He realized Friede might have exactly those broadly neutralizing antibodies they were looking for, antibodies that could work against lots of different venoms.
So he reached out.
He did, apparently called it an awkward question, asking Friede for blood samples.
And Friede's reaction.
Extremely enthusiastic. He reportedly said something like, "I have been waiting so long for this call."
Wow. He'd hoped his self-experimentation could lead to something bigger.
Seems so. He'd apparently participated in some smaller, unpublished studies before, but this was different.
So what's the science here? What makes these antibodies potentially, universal, or at least broader?
The key is that they are broadly neutralizing. Think of it like, instead of needing a specific key for every single lock, Friede's antibodies act a bit like a master key.
Okay, I get that.
They recognize and grab onto harmful bits, the toxins that are common across venoms from different types of snakes.
And in this first step, they focused on a particular type of toxin.
Yes, neurotoxins. Those are the main damaging components in venom from elapid snakes.
Elapids, like cobras and mambas.
Exactly. Cobras, mambas, coral snakes, kraits, that family.
So they took his blood sample, and then what?
They isolated some of his most potent antibodies, two specific ones actually, called LNXD09 and SNXB03.
Catchy names.
Yeah. They combined those two antibodies with an existing drug, Verisplidib, which also helps block certain venom components. They created this cocktail.
An experimental antivenom cocktail.
Precisely. And then they tested it in mice.
And the results, I remember reading, they were quite promising.
Very promising. The study, published in Cell just recently, May 2nd, 2025, it showed this cocktail gave mice complete protection against lethal doses of venom.
Complete protection. From how many types of snakes?
From 13 out of 19 dangerous elapid snakes they tested. Things like black mambas, several cobra species, king cobras, tiger snakes.
That's incredible. And the other 6?
It gave partial protection against the venom of the other 6, so still some benefit.
That really does sound like a potential step change, not just tweaking the old methods.
Exactly. It's moving away from animal-derived, species-specific stuff towards something potentially human-compatible and broad spectrum, a proof of principle.
What did other snakebite experts think? Were they excited? Cautious?
A mix, which is typical in science. Mostly positive, but cautious. Dr. Andreas Lostsen-Kiel called it perhaps the best combination published today, a real step forward.
Okay.
Professor Nick Casewell, who's a big name in venom research, called it certainly novel with strong evidence, but stressed, more research is definitely needed. It's still early days.
Still mice, not humans yet.
Right. And this current cocktail, it targets, 3 main toxin families?
That's what one of the study authors said, Peter Kwong. Out of maybe 10 families across all venomous snakes.
So hitting 3 key ones in elapids is a great start, but there's more work to do to get broader coverage.
And they're already thinking about other uses, like for animals.
Yeah, they're talking to vet groups in Australia. Could it work for dogs bitten by snakes? That's a possibility they're exploring.
Interesting.
And the future goals are clear. Try to improve it, maybe add a 4th antibody for full elapid protection, and critically, develop something similar for viper venom.
Ah, right, because vipers have different toxins.
Totally different. Vipers mostly have hemotoxins, which mess with your blood, cause bleeding, swelling, unlike the neurotoxins in elapids that affect the nervous system.
So the ultimate dream is one shot for any snake bite. Or maybe two.
That seems to be the long-term vision. Either one truly universal antivenom, which is incredibly ambitious, or maybe a two-part treatment. One for elapids, one for vipers.
That would be revolutionary for global health.
Absolutely.
Now, that review article you mentioned, the one from PMC PubMed Central, how does this new work fit into the bigger picture of antivenom history and development?
It provides great context. It explains that traditional method using hyperimmunized animal plasma, mostly horses, that's been the standard since the late 1800s.
And it mentions polyvalent antivenoms too, right? Ones that work against multiple snakes in a region.
Yes, it gives the example of Brazil, where they use a polyvalent antivenom against various Bothrops species, which are common pit vipers there. So the idea of cross-reactivity isn't totally new.
But it also confirms the problems we talked about with the traditional stuff.
Definitely. It goes over the partial effectiveness sometimes, the side effects risk because it's animal-derived, and how it often doesn't prevent local tissue damage well unless given super early.
And researchers have been trying to improve those old methods too.
Yeah, the review talks about optimizing how they immunize the animals, using adjuvants to boost the immune response, trying different animals like chickens, even using purified single toxins instead of whole venom to try and get better antibodies.
But the real buzz seems to be around these next-generation approaches, like what Centevax is doing.
Exactly. The review spends a lot of time on that. Monoclonal antibodies, MABs, and antibody fragments.
Monoclonal, meaning they're all identical and target one specific thing.
Precisely. Unlike the mix you get from Friede or a horse, these MABs can be designed to be super specific, potentially reducing side effects, and they can be produced consistently in labs, not relying on animals.
So more like modern drug development.
Very much so. The review traces this back to the first anti-snake toxin MAB in 1982. And now they're making humanized or fully human MABs to reduce immune reactions in patients even further.
And smaller bits too, not just full antibodies.
Right, things like FABs, SCFVs, even tiny things called nanobodies from camels or sharks. They're smaller, might get into tissues better, maybe more stable. Lots of research there.
It sounds like the whole field is moving in this direction, towards these more engineered, maybe safer antibody therapies.
That's the clear trend. The review suggests these recombinant antivenoms could eventually be safer and maybe even cheaper to produce than the old serum method. The tech is getting better, cheaper.
And less reliance on animals.
That's a big factor too, yes. Public and scientific desire to move away from that.
Okay, so bringing it back to the Centevax antivenom, the one using Friede's antibodies, it's exciting, but we need some caveats, right?
Absolutely critical caveats. First, as we said, it's experimental, only tested in mice so far.
Proof of principle.
Exactly. It's likely years away from human trials, assuming everything goes well.
And second, the current version only works against elapids.
Right. The cobras, mambas, etc. with the neurotoxins, it doesn't yet work against vipers and their hemotoxins.
But they are working on that.
Yes, the researchers are very clear. The goals are to improve the elapid coverage and definitely develop treatments for other venom types, especially vipers.
And we have to mention Tim Friede's own warning.
Yes, very important. He strongly warns people, don't do it. Don't try self-immunizing.
He stresses how incredibly dangerous it is.
Emphatically, his journey is unique, not a path for others to follow. It nearly killed him multiple times.
Okay, so let's pull this together. We've got Tim Friede's absolutely extraordinary high-risk story,
which led to the discovery of these unique, broadly neutralizing antibodies in his system.
These antibodies became the foundation for a new experimental antivenom from Centevax.
An antivenom that, in mice at least, shows broad protection against many deadly elapid snakes.
Potentially overcoming major limitations of current antivenoms, the species specificity, the production issues, the side effects.
And this fits into a wider shift in research towards next-gen antivenoms, like monoclonal antibodies, aiming for safer, more effective, maybe more accessible treatments globally.
The really aha moment here, I think, is seeing the human body's own potential. That someone's immune system could develop such powerful defenses against venom.
To the point where it could actually help create a potentially universal treatment. It's quite remarkable. Friede's unique immunity unlocked something vital.
And for you listening, you have to think about the implications if this research pans out.
It could drastically change the outlook for hundreds of thousands of people affected by snakebite every year, especially in vulnerable regions.
A huge potential impact on global health.
It really is. And it leaves you wondering, doesn't it, given how incredibly diverse and complex snake venoms are?
Yeah.
What other, maybe unconventional sources of immunity might be out there? in nature, maybe even in other people or animals exposed over time, things we haven't even thought to look for yet that could lead to the next medical revolution.
That's a fascinating thought to end on. What else might be hiding in plain sight?